So you see problem 1, force acceleration 3. And now you are already familiar with force acceleration method with the first 2 lessons. So instead of go ahead to take very long time to solve one problem, and that also take time for you to look at the video. So now I just want to highlight what are the key information with the solution that you have in the PDF, that hopefully it will be shorter for now, given that you already know how to solve force acceleration. So here we have mass is 10 kilograms. So you see that there. So we can have a properties with the weight, and then it also kg given. So the radius of gyration. So you can find out the IG, and this body apply the force P equal to 50 Newton. 50 Newton. So you have the load 50 Newton. So that load there. So the body will be a GPM, and as you can see, apply the force P going up. That will tend to rotate clockwise and move to the left, move to the right. And with that, we can go ahead to draw the diagrams. And in this case, only one body. So you draw two body, the wheel. So it will be free body diagram and the other kinetics diagram. In free body diagram, as you can see, we have the weight 91.8, 98.1 Newton going down. We have the load speed 50 Newton going up, as shown there. And then at the surface, the ground, we have the normal force vertically, and the friction force that we don't know. We can assume the direction. In this case, we assume go to the right. And I show you intuitively, if load P apply going up on the left side, it tend to clockwise rotation for the wheel, and also the center tend to translate to the right. So with that, we can have in the kinetic diagram IG alpha and MAGX. G not moving up or down, so that's why you don't have MAGY. So that go 3 equation, a y equation, we can find out the N, the normal force there. And then x direction on the free body diagram, we have the force F go to the right, so it's positive. Normal force will weight the 50 Newton, or vertical, so it's not involved in the x. And MAGX, it will be there, so you can plug in. The mass is 10 kilograms, so it will be MA10 AGX. So that one here, actually, it will be 10 AGX because the weight is 10 kilogram. And then we have moment about G. About G, center of mass. So you have the weight, the force 50 Newton, and it create clockwise about G. So that way negative, because we assume counterclockwise positive. And then the friction force is also counterclockwise from G. See that? And the moment arm is 0.4. So you have that on the free body diagram, moment about G. And for the kinetic term, it's IG alpha. So you have it 0.9 kilogram meter square. And because IG alpha in your kinetic diagram is clockwise, while you assuming your equation is counterclockwise there, that why it's negative there. Okay, so that negative in that equation. And then we go ahead to count how many unknowns. So you have that equation known already done. We have 1, we have 2 alpha, right? And then we have not here yet. Not here yet. We have 2, and we have 3, and 2 equation, 3 unknowns, and we don't have any other body, so we have to assume something. So always assume no slip, not slip, right? Assume no slip. So when it no slip, so you have AGX equal to alpha R, and it's 0.4 R. You plug into equation 2, so you have that one here, alpha R. So that 2 equation, 2 unknown, we can find out alpha equal to 5 radian per second square. And simplify the equation 2, we have F equal to 10 times 0.4 alpha, so that way F equal to 4 alpha. With alpha equal to 5, so you can have F equal to 20 Newton. And then ATX, because we assume no slip wheel, it equal to alpha R, so you have it 0.4 times 5, so 2 meter per second square, and it go to that way. And then because you assume no slip, so you have to check whether your assumption is good. So check no slip wheel assumption. Equation is FF equal to or less than mu sub Sn, and that is F max. So F max is mu sub Sn. The mu sub S in that case, they give us E 0.2 and mu sub K 0.15. So you can have 0.2. The normal force start from equation 1, 48.1. That is the normal, 48.1 there, Newton. So from that you will have the friction force equal to maximum maximum 9.62 Newton. And what we find out is 20 Newton. So it means that the friction greater than maximum. So this assumption is not good, right? What does that mean? No slip wheel assumption not good. So it will be the wheel slip. So that's why we have the wheel slip in there. So when the wheel slip, F equal to mu sub Kn. F equals mu sub Kn, and you also have ATX is not the same as alpha R. Keep that in mind. So why that? Go to note number 2, force acceleration 1. You will have a review of that. Or go back to rigid body kinematics 2. You have that slip or no slip wheel scenarios. So from that you use equation in here. For example, you already know equation F equal to 10 ATX, and F now is equal to mu sub Kn, right? So you can rewrite that equation. So F equation 3, so F equal to mu sub Kn and friction force. So you will be able to find out the ATX and alpha. So here you see no slip, so mu sub Kn, so that mu sub Kn here, so you can plug into that equation. 10 ATX equal to F, so 10 ATX equal to F equal to in this case 7.21. So from that you can have ATX equal to 0.721, and it will be meter per second square. Go to the right. Okay, and then similarly, that is from equation 2, by the way. And similarly, go to equation 3. We have negative 50.25 F.4 negative 0.9 alpha. So you plug that equation. So one equation, one unknowns. You also have alpha equal to that one. And as you can see, if you check now, you have ATX here. So you have alpha R equal to 10.68 times the radius of this one is 0.4. So it equal to 10.68 times 0.4 equal to 4.272. And that, as you can see, is different from ATX. So they are not the same. ATX is only 0.721 meter per second squared. So they are not the same. That's why it's not always A at the center equal to alpha R. It's always equal, and it's not equal. When it equal, it means that the wheel is no slip. But in this case, the wheel slip in, as you can see there. So keep that in mind. And this problem is somewhat similar to problem 4 in force acceleration 1. With that, we done for the highlight for the solution of problem 1, force acceleration 3.